Welcome to The Explainer. I am so thrilled to have you with us today because we're about to unpack a truly monumental shift in the world of naval warfare. We're talking about a piece of technology that is literally rewriting the rules of engagement out on the open ocean. And the craziest part? It's doing it completely autonomously.
So think about this for a second. Why send a multi-million-dollar stealth jet into hostile territory when a robotic boat can do the exact same job and, honestly, maybe even do it a little bit better? Historically, right, penetrating enemy defenses meant risking human pilots and incredibly expensive aircraft. But that whole paradigm, it's just been completely shattered. The economics and the physics of modern drone solutions are entirely taking center stage.
Let's just drop right into the action. Picture this. It's July 12th, 2026, at the Bandar Abbas Naval Base. It's the dead of night. There are no warning sirens ringing out over the harbor, no frantic anti-aircraft fire lighting up the pitch-black sky. Instead, slipping quietly through the dark water, an entirely uncrewed, silent boat is surging directly toward a heavily guarded dry dock.
Which brings us to Section 1, the dry dock strike, stealth and destruction. So, for the very first time in an active war zone, the U.S. Navy deployed this platform to execute a totally unprecedented kamikaze-style strike, using 3 synchronized drones. And what exactly were they after? Well, a Gadir-class midget submarine that was temporarily laid up in the dry dock. Now, these small diesel-electric subs are a massive, asymmetric threat. Because they're compact and incredibly quiet when they run on battery power, they are purpose-built for the shallow, crowded waters of the Persian Gulf. They lay down undetectable acoustic mines, they launch torpedo ambushes in the narrowest choke points of the Strait of Hormuz. So taking one of these subs off the board before it can even submerge, that is a huge tactical victory.
Now, you might be asking yourself, why not just use an F-35 stealth fighter to bomb the thing? Well, traditional coastal defense networks, those anti-access and area denial or A2/80 networks, they're primarily designed to look up at the sky. A small composite hull boat surging at 35 knots essentially just slips completely under their radar horizon. And while a top-down aerial bombardment is great for, say, inland bunkers, it actually often fails to achieve the devastating ship-breaking shockwaves that a low-cost, radar-invisible waterline strike can deliver.
All right, let's dig into the science a bit in Section 2, Physics of a Waterline Blast, Harnessing the Ocean. We really need to talk about what happens at the exact millisecond this drone, which is armed with a 1,000-pound GBU-31 payload, actually slams into the steel hull of that submarine. The secret weapon here is incompressible water. When that massive payload explodes right at the waterline, it literally harnesses the physics of the ocean itself. See, because water heavily resists compression, the explosive shockwave can't easily dissipate downward or outward into the sea. Instead, the path of least resistance is the target itself. All that energy is forcefully directed inward and upward, simultaneously shredding the submarine's steel pressure hull and completely obliterating the concrete dry dock supports.
Let's walk through the mechanical sequence of that blast because it's fascinating. The vessel uses an unguided, low-drag, general-purpose bomb from the U.S. Mark 80 series. The sequence happens in a flash. Step 1, the frontal nose fuse hits the target and activates. Step 2, a fuse conduit rod sandwiched right in the middle burns backward instantly. And Step 3, that massive 1,000-pound warhead detonates, creating a catastrophic explosion exactly where it hurts the most. But there is also a delayed option. Remote controllers can use the FMU139 tail fuse instead. When it hits the target, they can program it to delay the explosion for just a few seconds, which allows the bomb to penetrate really deeply into the structure before that 1,000-pound blast finally goes off. And here is the absolute kicker. This fuse system operates on a shockingly low $4,000 price tag. When you realize that taxpayers spend millions on a single Tomahawk missile, the sheer cost efficiency of this drone is pretty staggering.
Okay, let's hit pause on the destruction for a second. Moving to Section 3, Inside the Corsair drone, Anatomy of a Sea drone.
We definitely need to examine the actual internal engineering of this incredible vessel, created by Saronic Technologies, to see exactly how it pulls all of this off. On the outside, it looks deceptively ordinary, but this 24-foot autonomous boat is an absolute powerhouse. It can sustain speeds of over 35 knots, and it doesn't just sprint either. It's an incredible engineering feat that's capable of carrying its heavy payload across a massive 1,000 nautical mile range. Now, what's really interesting about this platform is that the Corsair isn't just a one-trick pony. Its weapons bay is completely modular. Yes, in the Bandar Abbas strike, it housed a 1,000-pound bomb on a custom launch cradle.
But depending on the mission, operators can swap that out, pack the hull completely full of raw TNT, or even configure it with a torpedoes deployment system. It is incredibly flexible.
So how exactly does it move so fast while staying undetected? Well, it all comes down to its hybrid power system. First, an internal combustion engine acts essentially as a high-speed generator, a range extender, basically. Second, that generator creates electricity to keep a really large battery pack fully charged. And finally, those batteries power a completely silent electric motor. That motor gives it rapid acceleration and drives counter-rotating jets, providing the vessel with precise speed, incredible maneuverability, and serious acoustic stealth.
Of course, a drone actually needs to be able to see and communicate, right? Up top, stealth truly meets sensing. The drone features a low-profile mast to limit its radar signature, but don't let that fool you. It is heavily packed with a camera suite and long-range radar. It also uses satellite uplinks for remote command. Together, all these systems feed crucial second-by-second data directly into its autonomous mission computer. This allows the boat to lock onto physical silhouettes and navigate entirely autonomously. No human intervention on board required. Which transitions us perfectly into Section 4, a historic autonomous rescue. No crew, no problem.
We're shifting gears now from a destructive, synchronized strike to a highly tense, completely bloodless extraction mission in the pitch black. It was June 8th in the Gulf of Oman. An Iranian drone directly rammed a U.S. helicopter. Miraculously, the drone's warhead actually failed to detonate, but the wreckage lodged into the cockpit and got the whole aircraft down. This left 2 U.S. pilots completely stranded in the dark water, floating in an active threat zone, heavily saturated with Iranian radar and actively patrolling drones.
The absolutely crucial point here is, how do you find these pilots without getting targeted yourself? The answer? Passive sensing. The Corsair used its 360-degree passive sensing capabilities to navigate the waters. Passive basically means it doesn't emit any detectable signals. No radar pings, no active sonar broadcasts. It remains entirely electromagnetically silent. It doesn't ping, it just listens. It autonomously navigated straight toward the GPS coordinates broadcast by the pilot's survival gear, completely avoiding painting a target on itself or the downed crew. In what was a historic first, the Navy's Fifth Fleet made the call not to send a manned search and rescue chopper or a Coast Guard cutter into that threat zone. There were no dramatic hoists, no searchlights illuminating targets for hostile radar. The 2 aviators simply used their own strength to pull themselves up onto the drone boat's deck, and the Corsairs silently transported them away to safety. The end result of that incredibly dangerous mission? No helicopter, no human rescue crew put at risk, just a robot.
And that brings us to our final use case. Section 5, Sweeping for Hidden Killers, Mine Warfare. Imagine for a second weaponized acoustic mines scattered all across the vital Strait of Hormuz. A scenario like this forces a really critical question. How on earth do you clear these hidden killers from the seafloor without risking human lives? Well, the answer lies in a completely new naval philosophy centered entirely around robotic motherships. Okay, let's dive into this LCS mothership strategy. Instead of sending in traditional manned minesweepers, drones, like the Corsair, are launched from Independence-class littoral combat ships. The human-crewed mothership stays safely tucked away outside the danger zone. Meanwhile, the uncrewed surface vessels deploy right off the stern ramp and go do all the heavy lifting. Operating completely autonomously, they drag advanced sonar equipment behind them, almost like a long, patient finger tracing the seafloor, to detect, localize, classify, and identify any anomalies down there. And here's how they actually neutralize those threats once they find them. First, the Corsair drags what's called an unmanned influence sweep system through the water. Second, this incredible piece of tech perfectly mimics the exact magnetic signature and the acoustic engine sounds of a massive warship. And third, the bottom-dwelling mines are totally tricked into thinking a huge target is passing directly overhead. They safely detonate right behind the drone, blowing up nothing but empty water. It is brilliantly simple, yet unbelievably effective. So, as we wrap up this explainer today, I want to leave you with a final, really provocative thought. With autonomous robots quietly executing bloodless rescues in pitch-black waters one day and flawlessly sinking submarines in synchronized kamikaze strikes the next, what is the true future of human naval combat? I mean, are we watching the sudden silent end of the human-crewed era on the high seas? It's a fascinating thought to take away from all this. Thank you so much for joining me for this explainer, and as always, keep learning.